Hey everyone, this is Mrs. Richard. This is our last video before we move forward with preparing for our assessment. So we're going to be comparing distributions. We've worked all week on understanding the difference between box plots, dot plots, and histograms and what they tell us, how they're skewed. Now we're going to compare them. In this example, the tables list the average ages of players on 15 randomly selected NFL and MLB teams in 2010. Describe how the average ages of NFL players compare to those of MLB players. So if you see, we have 15 data entries for each of the two teams, NFL and MLB. You could calculate the mean, median, IQR, and range using the data from the previous slide. You can either do that by hand or in Desmos, and this is what you get. This part right here, the mean and median, represent the measures of center. The IQR and the range represent measures of spread. So for our comparison, if we look at the mean and median of the NFL and compare it to the mean and median of the MLB, we notice the NFL has a smaller mean and median, meaning they have younger players on average. The MLB has more of a variety of ages than NFL if we compare the measures of spread, because they have a bigger IQR and a bigger range. So if you notice for IQR and range, the MLB values are higher than the NFL. Why might this be? Football is tougher on your body than baseball, so you can play baseball for more years than you can play football. You'll probably have fewer injuries in baseball than football. For our second example, we're going to look at the dot plot, box plot, and histogram below that represent the same data set. They show test scores as percentages. So we have the dot plot, where you can see individual values. The histogram, you can see the bins of values, the ranges of values on the bottom with the frequency on the left side. And then for the box plot, you can see the box and whisker plots with the 5-number summary of the test scores. We're going to use these 3 graphs to answer a series of questions. How many students took the test? Which representations show this number? We can look at a couple of different representations. I know that 22 students took this test. You can count the number of dots on the dot plot, or you can add the frequency of each column in the histogram, 2 plus 11 plus 9. The histogram is showing 2 students scored between 70 and 79. I don't know their exact scores, but I know they fell within that range. 11 students scored between 80 and 89, and 9 students scored between 90 and 99. But I know that those frequencies I can add up. I can also add the dots. The number of dots show the exact score of all 22 students. What is the mean of this data? Which representations can you not use to find the mean and why? I think it's easiest to use the dot plot in this case, where I'm going to just add 70 plus 72 plus 80, 80, 80, 80, 80, 82, 80, 44, etc., and divide by our 22. You get approximately 85.91, and of course you can list them in a table of Desmos, and I suggest you doing that on the assessments. You cannot find the mean using the box plot or the histogram because you do not know the exact data values or how many total data values you have using those 2 diagrams. We know that we have 2 test scores between 70 and 79, but we don't know what they are. And then also for these test scores, we don't know how many scores fall within each of the 25% quartiles or what exactly those values are. The dot plot is the only one that we can know for sure. What is the median of this data? Which representation did you use to find the median and why? You could find the median using the dot plot by going through and crossing out the dots one at a time, or you can simply look at the box plot. If all of these values were listed clearly, you could see that the median is 88. You can find this on the box plot since that middle line of the box plot shows the median. What is the mode of this data? Which representation shows the mode? In this case, I see in the histogram that 11 students fell between 88 and 89, but I don't know what the actual test score was where most students scored. So I can use the dot plot, and I see that 80 and 92, 5 students scored 80 and 5 students scored 92%. You can only find the mode using the dot plot because the histogram and box plot do not show individual data values. What is the range of this data? Which representations show this value? We can look at either the dot plot or the box plot. I know that the maximum is 98 and the minimum is 70. If you subtract those, you get a range of 28%. You can find the range using the dot plot or box plot because they show both the minimum and maximum values. The histogram shows ranges, but it doesn't necessarily show the smallest and highest values. Maybe the smallest value was 71 and the highest value is 97. I don't know that specifically from the histogram. What is the interquartile range of this data? Which representation is easiest to see the IQR and why? While you could use the dot plot above to manually find the IQR, it might be easier to use the box plot. Quartile 3 is 92 and quartile 1 is 80. If you subtract these two, you get 12. The box plot is the easiest to use to find the IQR because Q3 and Q1 are given in the box. We know that 50% of the data lies between 80% and 92%. So 50% of my students scored between an 80% and 92%, a B to an A minus. This last example has box plots, but has two of them on the same grid to compare students' test scores in first and second period. I see that in first period, I have at least one student who scored lower than second and higher than everyone in second period. I also see that my median is lower in first period than in second. For the question, we have which class scores better more consistently. When you're looking at consistently, you want to look at your IQR and the range, the measures of spread. Second period scores more consistently because it has a smaller range and smaller IQR, a shorter box when you're comparing them apples to apples, side by side. Now I'm going to ask that you ask your teacher any questions and enjoy your practice. Good luck and have a great day.